Have you ever wondered where our Earth, our home, came from? It's a question that tickles the human mind, a cosmic riddle that scientists across the globe have been trying to unravel for centuries. This isn't a trivial pursuit. It's a fundamental inquiry that seeks to understand our very existence, our place in the universe. The origin of Earth, the birthplace of life as we know it, is a topic of great scientific intrigue. It's a puzzle that has been pieced together over time, through the collective efforts of astronomers, geologists, physicists, and chemists. Some pieces of the puzzle fit neatly together, while others still remain elusive, sparking debates and driving the quest for knowledge further. Now, let's dive into the cosmic ocean and explore one of the most widely accepted theories about Earth's origin, the theory of solar nebula. This theory paints a fascinating picture of our planet's birth. Taking us back in time, around 4.5 billion years. Imagine a massive swirling cloud of dust and gas. This is the solar nebula, a primordial soup of sorts. According to the theory, our Earth, along with other celestial bodies in our solar system, was born out of this cosmic cloud. This wasn't a rapid process, mind you. It took millions of years for the dust and gas to gradually come together, forming clumps that grew larger and larger, eventually giving birth to our planet. The solar nebula theory is supported by various lines of evidence, from the chemical composition of meteorites to the rotational patterns of planets. However, it's important to note that while this theory answers many questions about Earth's origin, it also raises new ones. And that's the beauty of science. It's a never-ending journey of discovery. So, our journey begins with a cloud of cosmic dust and gas, swirling in the vast emptiness of space. As we delve deeper into the story of Earth's origin, remember that each piece of the puzzle not only teaches us more about our past, but also sheds light on our future. In the heart of this cosmic cloud, something incredible began to happen. As if drawn by an invisible hand, the dust and gas particles in the nebula began to move closer and closer together. This was gravity at work, the same force that keeps our feet on the ground and the planets in their orbits. This nebula, a majestic cloud of cosmic dust and gas, was not just a random patch of space. It was a stellar nursery, a place where stars are born. And in this particular nursery, a new life was about to begin. As the particles came together, they formed a dense, hot core. This was the birth of a protostar, the first step in the formation of a star. But this was just the beginning. The protostar was still too cool and too small to become a full-fledged star. It needed to grow, and it needed to heat up. And so, it did. The protostar continued to collect more and more matter from the surrounding nebula, growing in size and increasing in temperature. The pressure in its core became so intense that it sparked the process of nuclear fusion. Nuclear fusion, the process that powers the sun and all other stars, is a bit like a cosmic pressure cooker. It happens when the cores of hydrogen atoms come together under extreme heat and pressure to form helium. This process releases a tremendous amount of energy in the form of light and heat. And just like that, the protostar was no longer a baby. It had grown up and become a star, shining brightly in the cosmic night. This star was our sun. It was not just any star, but a special one. It was the star that would eventually give birth to our solar system, the star that would provide the light and warmth necessary for life to flourish on Earth. With the birth of the sun, the stage was set for the formation of the planets, including our Earth. Around the newly formed sun, a swirling disk of dust and gas remained. This celestial carousel, spinning in the darkness of space, was the cradle of our solar system. Amidst this cosmic chaos, the process that would eventually lead to the formation of our beloved Earth began. This process is known as accretion. Accretion, in simplest terms, is a cosmic game of marbles meets magnets. Tiny dust and gas particles swirling around the sun began to collide and stick together. Think of it as a snowball effect, but in space. These tiny collisions, over millions of years, gave birth to larger bodies called planetesimals. Planetesimals, the building blocks of planets, were not merely giant rocks floating in space. They were dynamic, active bodies. They had their own gravity, and as they moved through the swirling disk of dust and gas, they attracted more and more material. Over time, these planetesimals grew larger and larger, colliding and merging with each other. This chaotic dance of growth and collision wasn't a smooth process. It was violent and messy, with planetesimals smashing into each other, breaking apart, and then reforming. But out of this cosmic tumult, larger bodies began to emerge. These were the protoplanets, the precursors to the planets we know today. One of these protoplanets, through countless collisions and mergers, accumulated enough mass and material to stand out from the rest. This was the birth of our Earth. In its early stages, the Earth was a molten mass of rock, heated by the energy of countless collisions and the radioactive decay of certain elements. From a cloud of dust and gas to a molten mass of rock, our Earth was taking shape. It was a process of transformation that spanned millions of years, a testament to the incredible power of natural forces and the fascinating complexity of our universe. And this was just the beginning of Earth's extraordinary journey. In its early stages, the Earth was a fiery, molten world. Picture a planet ablaze, a sphere of raging fire and scorching heat. But over time, this fiery globe began to cool, setting the stage for the world as we know it. This cooling process was no quick change. It took place over millions of years, a blink of an eye in the grand cosmic clock. The Earth cooled from the outside in, creating a thin, hardened crust on its surface. This crust was not the solid, unchanging surface we walk on today, but a shifting, evolving layer. It cracked and moved, creating the first continental and oceanic plates. These plates floated on the molten rock below, colliding and separating in a slow dance that shaped the features of our planet. But the Earth's cooling did not only affect its physical structure. As the Earth cooled, it also changed the planet's atmosphere through a process known as volcanic outgassing. This is not your typical gas release, but rather a vast release of gases trapped within the Earth's interior. Volcanoes acted as nature's pressure valves, releasing these gases into the atmosphere. The gases released in this process included water vapor, carbon dioxide, and other trace gases. Over time, these gases accumulated, forming the Earth's early atmosphere. This atmosphere was vastly different from the one we breathe today. It was a heavy, dense cloud of gases, devoid of the oxygen necessary for life as we understand it. The water vapor released through volcanic outgassing also played a crucial role in the formation of the Earth's oceans. As the Earth cooled, this vapor condensed, forming droplets that fell to the surface as rain. Over millions of years, this rain accumulated, filling the low-lying areas of the Earth's crust and forming the first oceans. So, from a fiery, molten world, the Earth transformed. It cooled, developed a crust, formed an atmosphere, and filled with oceans. As the Earth cooled, it began to look more like the world we know today. This cooling process was a pivotal chapter in the Earth's history, setting the stage for the development of life and the world as we know it. Fast forward to today, and we find ourselves on a unique planet, a sphere of wonder, home to an astonishing array of life forms, from the smallest microorganisms to the largest mammals. Our Earth, in all its splendor, is truly one of a kind in the vast expanse of the cosmos. Let's consider some of the Earth's distinct features that make it special. First up, the atmosphere. This protective shield not only provides us with breathable air, but also acts as our planet's first line of defense against harmful solar radiation. It's a complex mixture of gases that has evolved over billions of years, shaping the conditions for life as we know it. Then there's the magnetic field, that invisible force field that protects us from solar winds and cosmic rays. It's generated deep within the Earth's core, where molten iron swirls and churns, creating a dynamo effect. This magnetic field is a key player in making Earth a habitable planet. And of course, there's the presence of life itself. Earth is the only place in the universe where we know life exists. From the deepest oceans to the highest mountains, life has adapted and evolved in a myriad of ways, showing an incredible resilience and diversity. The understanding of Earth's origin gives us a profound appreciation for our planet and its place in the universe. It reminds us that we're part of a bigger cosmic story, a tale of creation and transformation that began billions of years ago. It's a story that continues to unfold as we learn more about our planet and the universe that surrounds us. So next time you gaze at the night sky, remember the journey our Earth has taken. From a humble cosmic cloud of dust and gas, through fiery birth and icy ages, to become the vibrant, life-sustaining world we call home. From a cloud of cosmic dust and gas to a unique world teeming with life, that's the fascinating story of our Earth's origin.